Thanks, Paf, for the introduction, and thanks, CERIAS Symposium organizers, for giving me this opportunity. Indeed, here I'm talking about something which you have been hearing quite a lot, and like as Paf said, in the media as well. And what my aim here is to provide some of the interesting things that are happening in this space. And obviously, I'll be selfish and more focused on things that interest me. And my aim is to just give a brief overview, but I'll be more than happy to have your questions in the end or afterwards in the hallway, if particular thing that you wanted to ask about. Indeed, the title for the talk is a technical perspective for the blockchain things and what's happening in that space. So I'd typically like to start this talk of mine by looking at this, how our communication landscape is changing. And maybe we saw that in the beginning of this century that we started to become from local to global. What I mean by that is that we no longer relied exclusively on the local partners, but instead we started to have companies such as Airbnb and Ubers and Amazon, so that it's global, it's same thing works everywhere with the same account, and I can just go and use it over there. However, one key thing which was different there was the centralization, that there's still one organization or one body, one governing body who was making decision there. And actually started from the subprime in 2008, it laid in one particular sector, the payment sector, the innovation in terms of the Bitcoin, and which lead to several different cryptocurrencies, where idea is that the governance, both aspect of it, like making the rules and following the rules, is now distributed. And that's done by a completely distributed or decentralized system, which as long as half of that is working correctly, will continue to function correctly. Initially, the industry was not so much interested about it, but maybe 2013 onwards, it indeed started to happen that where people say that, hey, the core idea can be applied beyond money. I mean, we can take everything as an asset, and then we can use that for and use that to actually track different things. And basically, as I write there, it's like people are trying to do blockchain for everything. As a technician, it's my task to indeed ask that question for the first time: is blockchain really required here? But indeed, there are in some genuine scenarios where it is applicable, and that's what we try to focus on. So the rhetoric typically used to say that cryptocurrencies may or may not survive, but blockchains are here to stay. I think even maybe the first part itself, I may say that maybe they have enough potential to survive by now, but let's see what happens with themselves afterwards. So this is just, I'm showing, this is quite old and showing just some of the players in this space where there are interesting things happening in the industry at the core level itself, going up to the application layers and how things are progressing in that space. My aim is just to show that there's a lot of startups and big companies who are in this space working, and there is a lot of potential, which probably I don't think I need to tell in this audience. But I want to start my talk by giving a very interesting way to look at this whole concept, and that's that initially it started as something as a currency or money. So what is money? It's actually a store of value in basic principle, which means that people can save it and use it later. It's not like bananas, which I can't use as a store of value because they'll go bad, or oranges. Okay, it's something which I can keep in wallet and can remain there for a really long time without getting hampered. So that's the advantageous thing for the money. And then it's unit of account, so that we can use that to compare things in a very fine-tuned manner. I know that my laptop costs more than a table or stuff like that, and I can compare them precisely because of the monetary thing associated with that. And that's the reason it becomes a really good exchange of medium of exchange. And money, we have used a different kind of money throughout our human history. And I want to take a very interesting example, which some of you might have seen or not. And this is on Yap Island in Pacific. They use a very interesting kind of money. They call them stone money. They are big discs like that, as I'm showing on there, and with a hole in between, and they cannot be queried on that island. So they have to go to some other island, query them, and then bring them back to the island. And they use this as a currency. Their aim is that it's a small island, so say that that stone currently, which is lying at that particular location, now initially belonged to person X, now it will belong to person Y. And they just tell that to everybody, and everybody remembers, and that's how they try to keep account of everything. In fact, there is a very funny story there that once they were querying some stones, and the ship capsized and they fall off. But the people survived. They said, yeah, we queried them, but we can't bring them. And they said, don't worry, we'll still count them. We'll see that those who are sitting somewhere at the Pacific, we are going to use them as a money and use them as a. So the key thing to remember here is that for any monetary system, what we have to remember is the oral history. As long as we know, can remember, or maybe I'll focus on the word history, or maybe I'll then use the word ledger. So as long as we can keep a ledger, we can use that to count money and maintain a complete ledger over how it is transferring. We don't need to have a physical instrument for that purpose. And that's a maybe basic idea behind all this, maybe initial idea behind all Bitcoin and other cryptocurrency systems. So if you look from the core idea itself, as I was saying, it's a ledger. So the first thing is the blockchain, and actually it comes in now different forms, but I'm still maintaining the basic thing. The keyword I'm focusing here is the asset. So although it's initially started for a currency, but it need not to be currency. It can be anything that you want to keep track of, and that's where the other application in the industry comes in picture. You want to make sure that you aggregate this information and put them in a block so that you cannot change the order. It's only append only. You can append something, but you cannot remove easily. And those are the properties that you want. And eventually, you want to make sure that there is a unique order that's followed so that I know I can keep track of how assets are moving. Okay? The replication is important because if information are there but not available, then you can't use it. Another important thing is that you want to make sure only correct participants can take part into the system. And that's where the concept from cryptography comes in picture, where you need to introduce some kind of a signature infrastructure to ensure that correct participants can add and verify the information. And the most, I'll say, the innovative part that comes in picture is the consensus mechanism, a smart contract, where you say that why don't we just not only have this as a storage, but also introduce computations which are inherently distributed and now perform computations on that data and basically introduce business logic into the process. So basically, smart contract is the word smart there is overrated. The contracts there are basically a way to introduce the business logic into this ledger system, okay, and use that to build interesting aspects. So if you look at the applications, there are multiple applications, but I typically try to categorize them into payments that we're already talking about. Like there are systems like cryptocurrencies. There are also interesting concepts like credit networks like Ripple and Stellar, which are a very interesting concept. Okay, I'm not saying that these are all cool. Some of them have some very interesting practice which I don't agree with, but they're still nice examples which are working and prominent in practice. So their aim is basically, they call it like developing internet of value, right? You want to build a complete infrastructure. The way our emails flow together today at fast speed, can our transaction also speed at the same pace or not? That's the aim that we look for. Another set of things that I try to add here, and where the industry is interested these days, is that okay, go beyond money, take other assets. Like let's say, I'll just start with the example of identity. That's where the identity escrows and like identity database comes in picture. That can be built federated identity concept using blockchains. But we don't need to stop there. We can also have diamonds, good, any such physical objects, as long as we can precisely associate IDs to them. And even softwares can be added to such system, and that's where certainly something very interesting that could happen in this space. So this is like overall interview. Then I want to give maybe some technical details and interesting questions that are present in all these different spaces. So I'll start with what they are called as cryptocurrencies or permissionless systems. These are systems like Bitcoin and other systems where there is no precise, anybody can join and anybody can leave at any given point of time, and what kind of things we see there. So why are the cryptocurrencies interesting? I mean, initially, they thought to be fast, so that's the reason I said were arguably fast. It's no longer considered very fast enough, but indeed the 10 minutes of agreement time on Bitcoin was considered to be fast enough in the beginning. Okay, they were cheap, or some of them are still cheap, but certainly not Bitcoin. So that was the thing. The important thing is indeed there is no central authority, such that then the rules are made in a distributed fashion. And that was certainly initial attraction for sure. And it's digital, but has still some privacy property. It's at least in the basic concept in system like Bitcoin, it was weak. But we have really strong solutions now with really good privacy there. And some people actually find that to be advantageous, given the open nature of this general system. So indeed, it says that we have to find out solution which works perfectly with our infrastructure and our regulations today, but the ideas are there, they are proven to be solid, and we can use them to build next solutions in this space. But that's just for currency. Another interesting thing that I have to talk about is Ethereum. So the idea here is that why don't we just allow the monetary transaction, but go beyond and try and allow computations which are in general, which are, as we call in academics, Turing complete. Basically, that means anything that you can complete. And basically, that the idea here is there will be a contract which will be a program itself, which will live on these distributed systems where multiple users can interact with such a program. And every time you send a particular transaction to this contract, it will have its own state. It's going to process this transaction, change the state, and possibly give you some output. And this all is happening, again, not by one entity, but actually by a complete distributed systems. Okay? You can so precisely specify that what kind of trade-off you are looking for in terms of the performance versus security, or performance versus reliability, which can you introduce by writing this contract. Because this one can just look at as a complete distributed program by itself. Okay? And there are languages which are available there to write these contracts, and there are issues with those languages themselves, but still a very nice innovation. I mean, there are various ways one can use it, though, but one of the popular way associated with that is the Decentralized Autonomous Organization, or DAO. And so the idea here can be, let's say let's say we want to look at the crowdfunding, like you want to say, there's a project and we want to see if there are enough people interested with their money to invest in such system, then the project can go forward. But people do not want their money to get stuck in such a contract. So I'll pledge money and say that, okay, as long as this particular system raises maybe $1 million in this given amount of time, then you can use my money. Otherwise, I want to get back my money. And we want to ensure that no individual do that, but instead the complete distributed contract does that. And that's certainly the one example DAO. But in Ethereum space, there are certainly very interesting examples and applications that are getting built itself, which is certainly, there is a lot of opportunity for innovation in this space for sure. Okay, so that's the good part, but what are the challenges here? And I can certainly, there are more, but I'm certainly going to focus again one which I'm interested in these days is privacy, regulation, scalability. So it's known in Bitcoin situation that actually when you perform a transaction, although your real name never resides there, however, people can still track the transaction. They can say that, okay, how is money getting spent? And they can try to link, although not your names, but your different pseudonym as you perform transaction. So as I'm showing over here, let's say A and A prime are the pseudonym for the same person. These are basically their public key hashes. And he's paying 1 Bitcoin to, let's say, user B. And now you can just look at all this money and keep track of who actually A is here, because the money goes to B and the rest of the balance go back to his own another account. And you can take all these different transactions and link them across. And the question is, okay, this is still, there is no name associated with any of them to the user A here. Or let's say it's Alice, okay? The problem with this such linkability attack is that once any one of them get revealed that, oh, this identity, let's say A double prime belongs to Alice, now you can link all the other transactions of Alice to herself and you that, oh, all these transactions are performed by Alice. And there can be huge risk associated with that, because unlike in the centralized system, now only the chess or Visa knowing what I'm doing, now if there is a public ledger, it's available for everybody to analyze, and people have analyzed this to find out very effectively how different transactions or who performing which kind of transaction with whom. So there is these are ledgers publicly available, and people have been analyzing them for a long time. I mean, here I'm just showing a really small list of the such things which looked into different like Bitcoin and other systems and tried to analyze and find indeed who performed transaction, what are the frequency of the transaction for different players, and that can be indeed used to find out the transaction patterns, and competing organization we can use the information for all different purposes. Okay? So I mean, this is again not exhaustive list, but then why is this a big deal? And certainly, if you look at like EU's GDPR or other such things, they strictly prohibit that precise things, that where it should people who wants privacy obtain that privacy for their transactions. But if you say that your competing organization now knows who is performing transaction, or who are your suppliers and what are their frequency, how much you pay them, that's certainly not something which organization wants in such environment. So indeed, that's one more thing. Individuals may also do not want others, their neighbors or their other family members to know what kind of transaction they are performing, or just in general. So It's certainly, I mean, these are just small set of examples, but I can think of several other cases where indeed we have to make sure that the financial transaction need privacy, which is not present in system like Bitcoin. So what can we do then for the privacy? And there are different challenges. There are some kind of challenges where we take the existing systems and try to add something to it. Okay, let's say Bitcoin and add some more privacy to it. Or other approach is that no, we start currencies which are different but have better privacy property for the users. And we have solutions in all these spaces. I mean, there are some solutions for mixing and stealth addresses which are sometimes used in the systems like Bitcoin to improve the privacy. But there are also other systems like Zcash, and I guess one of organizers is here at Purdue. I think she was attending, but maybe I can't see her here. So Zcash, or there are some other examples where the aim is to actually have systems which are by definition have better privacy, which we can employ for all systems. So here I'm just making a list, and I don't mean to actually give any technical details here or cryptographic details here. But the key message there is that all these have their own advantages, disadvantages, and it's basically indeed it's a zoo. And the aim is that we have to take our own application space, see what kind of privacy we want, and respectively then go after a solution which is helpful for us. Okay, there are some of these solutions which are generally quite good and can work pervasively, but they also come with assumptions. For example, SNARS can be a good example to have any generic system, but they have their own small assumptions which we have to consider before we use them. Another thing which is necessary to consider is the regulation, and I'm pretty sure that ransomware is certainly something which many of the industry people are typically consider and worry about. And Bitcoin was used several times in those systems as a monetary way to get, and so are the other things like Silk Road. And indeed, we want to make sure that there is a better regulations about how transaction happen in such environment. And some steps are happening all over the world, but more efforts are certainly required. Another thing is, I guess, the value crash, and any time the Bitcoin value crash, I mean, as it happened recently and continues to happen, it's a big news. And certainly, again, maybe we have to see what kind of things play a role in that, and if you want to have a good cryptocurrency system which is less prone to such externalities, maybe some more efforts are required in that space. However, I'll say that it's still possible. I mean, it's easily possible to regulate all the transaction when money get converted from Bitcoin to other currencies like dollars or other things. And there is already, even in US, there are regulations in place to deal with these exchanges, and that's happening all over the world. And that's certainly one way to keep track and introduce the regulation the way we want in such environment. But certainly there's more efforts that we can put in this space for sure. And if you look at the systems such as Silk Road and other, we have found out that our forensic techniques still continue to remain reasonably good, and combining the physical evidence or evidence from the forums along with the cryptocurrency, we are able to actually overcome the challenges that are presented by usage of this system. One more thing I want to add here is that when we get an evidence in such system, it's much more foolproof because nobody is able to tamper that. So I find that to be advantageous as compared to some extremely black box kind of environment that present in the banking system otherwise, where people may tamper the logs and actually incorrect person may get actually prosecuted than somebody who actually did something wrong. So here at least everything is transparent, so which I find to be an interesting asset in this space. Another thing that's happening in this space that obviously, for even a Bitcoin transaction, let's say I want to perform that, I have to pay fees of easily $50 or even more today. And the challenge there is that can we do something to actually reduce the effort, so that can we build application, what we call as layer 2 applications, which build on top of blockchain, but they only use the blockchain for bare minimum applications, and the rest of the things happen off chain, means just as a normal communication. So you introduce interesting contracts, like here, which is known as payment channels. So the payment channel should be looked as a gift. I'm putting money in the gift card and continue to use that over some period, and at the end of the time period, I should go and settle how much I paid, then I have to give that and take back the money. And the idea is that we can build such interesting contracts on top to reduce our reliance on blockchain to perform transaction. It's efficient in terms of the time, because this can happen just in this particular off-chain is a transaction is just basically sending us digital signature. There is no fees involved because it's direct and you don't need to do anything with the blockchain, so it's very interesting in that space. And it also allows us to basically go beyond just one hop and perform multi-hop transactions with fees there in that scenario, but that can also bring interesting application to just talk to any, perform transactions with anybody without even having any such channel with them. So those kind of concepts that I envision here, we can just look at in terms of what are known as payment channel network, where the idea will be all these participants, they will put some money on each of their this gift cards, these payment channels, and they are locked as a transaction to the blockchain network, and then they'll just use this infrastructure for some time to perform transactions in a completely off-chain manner, as if just sending one signature. Okay. There are big challenges here as well. I mean, privacy is a challenge because these now guys in between can indeed determine what are the transaction volume and who is sending to whom what kind of transaction. And so is the reliability. Any of these guy in the middle goes down, again we have an issue that how to deal with that, because then we cannot use that link associated with this person. Let's say here Bob goes down, we cannot perform, Alice here cannot perform transaction any of the Carol or Dave. So interesting challenges are still present over here, but their business is like even Visa, for example, they think that this has the potential way to collaborate, where indeed they can introduce these intermediate hops with high availability and allow people to perform transaction to that. So their aim will be, we'll charge you a small fee, but then we'll provide you a very high availability so that you can perform transaction through us. We have a SATC NSA project associated with this concept and looking into the privacy and reliability issues in this space. So what's in the near future? I mean, the one thing is obviously people are already talking about connecting all these blockchains with each other. So there are concepts like atomic swap or interledger, where you take different blockchains and let's say, can I perform a transaction which goes across different blockchains simultaneously? Okay, and so that then we can, let's say I take, let's say I have my own blockchain associated with my company and I want to use Bitcoin or the system for payments. Can I perform transaction which simultaneously happen, that goods is transfer here and the money is transferred on the other side? So that's certainly something, there are interesting things happening in that space. The key issue there will be secure interoperability, that different blockchains speak in different languages. Can we make them talk in language which such that they can indeed communicate in a manner where the security is not lost? And so is the privacy, similar to the payment channels. Proof of stakes coming, why to burn coal and why to burn the electricity for generating. Interesting research is happening in terms of proof of stake. And why to have a chain? Why not have different data structures in that space? So another interesting thing is replacing the ordered chain by directed acyclic graphs or DAGs. You might have also heard them hash trees that people use in industry sometimes. It's also coming, and there are interesting challenges which remains to be solved, but we can certainly study that. So that's for the permissionless system. I know I'm just briefly giving brief introduction, but yeah, in 30 minutes that's what I can do. And now I want to use my last 5 minutes or so to talk about what's happening in the consortium or permission systems. These are the places where for a company itself, a consortium want to build such a system for their own use, and what can they do in that space. So the permission system idea is that there are also solutions which are in the middle at different locations. But then idea is that at least the decision making, the governing body is still predefined, and it's permission in the sense that you can add new players, but the existing people have to allow them to see. And that's certainly something that happens in permission system, where it's a predetermined but adaptive set of validators that perform the transactions. And then you use the concept of asynchronous atomic broadcast to achieve that system. The key advantage here is we don't need to perform proof of stake or proof of work kind of systems. We can rely on good old distributed system assumption that as long as honest majority is there or 2/3 majority is there, system will continue to work. So it's fast and cheap for sure, no doubt about it. But there are restrictions obviously in the place. Hyperledger is one of the prominent open source collaborative effort in that space, and many of you who are in industry might have been visited by IBM regarding that. So that's certainly one of the prominent things. But there are also other examples like Corda, multi-chain, which are happening in this space. So what kind of problems that we can solve with such consortium system? And supply chain is certainly, as I mentioned, a very interesting thing. So if I look at the traditional supply chain, we can look them as a multiple bilateral links joined together to form a chain. And the words are important. So they are bilateral links, but they're still not connected. They are just bilateral each, but they are not actually, there is no communication between two links. And that's a challenge that we have with the supply chain today, that let's say supplier A and supplier B has a ledger, supplier B and supplier C has ledger, but they don't have anything together. And that's certainly the challenge that we present here. And that's the reason like most supply chain today fail to make their process transparent across links. And that's a key challenge in this space that we want to solve. If you look at the solution like RFIDs, PUFs, they are present there and they can introduce unique IDs, which is good, which is a nice step towards in that space. But they still do not solve the software problem or the ledger problem. Because it's still possible for like insiders to create fake logs or tamper logs based on what they see and how they process them. So that certainly is a problem. And that's where blockchain comes in picture, where they can actually join these links to create form a chain or form a ledger chain at the level of the ledger itself to perform tracking across different situations. So this is a project that I'm going for Northrop Grumman for last 2 years, and where we try to with them we started to understand what precise things we can do in such supply chain situation. There are interesting challenges in this space. We can use a blockchain system to build the basics infrastructure, but access control is a huge challenge. So is the verifiability of the program. And as well as, let's say, based on the different goods that we add to the such supply chain system, that brings its own challenges. So I think there is significant more academic involvement is required to bring the supply chain close to the blockchain and use them for practical use in the practical systems in general. So then I want to just take maybe 1 minute to talk about what I find and what excites me in the next. And actually that's also very closely related to the two key terms that you have heard. And people are already talking about combining, or can we employ blockchains for the purpose of making transparency or build the logs on IoT, creating the ledger for IoT systems so that we can find out perform good tracking in that situation. It's not certainly a natural fit. There are issues such as resource constraint, disconnectivity of the network, heterogeneity of the system, which is inherent to the IoTs. And all these huge components that we required with blockchain may not always work there. So indeed, we required more efforts in that space, and that we have to work on for sure. However, I think there are interesting challenges, there are interesting possibilities we can consider. So in the blockchain system as clients and server. But what if we have hierarchy, more like this edge computing as we call, which is also inherent in IoT space. There can be low-level sensors, and then we can have introduce mid-level devices like routers, who themselves can help to some extent. And then we can have a click of high-level command and control systems to actually do something which build a hierarchical structure and use that to actually get the provenance and get the tracking that we want to achieve. The reason I'm using word reinventing there, because the current blockchains certainly do not have this capability. We have to actually build new solutions from the academic level, prove that they make sense, and then use this in the IoT scenarios. And that's certainly something which excites me more. There are also interesting issues in terms of ordering and validations, where can we differentiate them and do interesting things in that space. So yeah, a lot to be done in this space. And with that, I'm going to end my discussion. If you are here at Purdue, I run a weekly seminar at 2:30 to 3:30. I'll be happy to see more faces. We have people from all backgrounds, from liberal art to computer science, attending that discussions. But I'll be certainly happy to see more people joining me. And yeah, we are thankful for NSF, Northrop Grumman, and Ford Motor for their help for our research so far. But we are certainly looking for more collaborations with the industry going forward. Thank you.